Good morning, ladies and gentlemen. Today I want to tell you a story. But before I tell you the story, something just happened this morning. And since our project is about the news, I thought it was very important to include this. So let's read today's news together. So Donald Trump declares plans to purchase shares in the pyramids as a source of investment for the United States of America. To quote him, I've been hearing a lot about these pyramids, folks. And let me tell you something. I'm all about good investments. We'll make Egypt great again. We're going to make pyramids work for us. Tremendous returns, believe me. It's going to be the best thing ever for the United States of America. People are going to be talking about it, and people will love it. That's insane. That's crazy, right? Can you believe this? Donald Trump actually wants to buy shares in pyramids, our pyramids? Do you believe it? I really hope you didn't, because that's absolutely fake. We fabricated this. We came up with it fully. It's misinformation. And this is a really good segue into our actual topic of discussion today, which is misinformation detection in news articles. So, to start off, our team members, Abdurrahman Magdi, Farah Fathi, Ahmed Mu'min, Amr Hussein, Abdurrahman Talat, Habib al-Sayed, and myself, Ali Fakhruddin. Today's topics of discussion are as follows. Let's get started with the introduction. So our problem statement was that misinformation in news articles is a growing challenge, which makes people confused and the public confused and not able to stay up to date with actual factual information and not just false misinformation. And in this domain specifically, it is absolutely crucial to have and maintain trust in the accuracy and integrity of news reporting. So in this day and age, anyone can tell their story, which is wonderful, right? So the voiceless have a voice. And that sounds in theory amazing, which it is. But like a lot of things in life, with great upsides, sometimes there is a great downside. In this case, unfortunately, anyone can have an opinion, which is wonderful, except because anyone can have an opinion and publish it, opinions can be disguised as facts. And when opinions are disguised as facts, this is very dangerous, as it can cause issues such as division and violence. When opinions confuse people enough to do so, it can cause violence and aggression. And it's important to highlight that misinformation and fake news, they thrive on times of crisis and chaos, where communities are meant to be together, where communities are meant to be tight-knit and supporting of each other, hold each other up when they're weak, except that this causes division, chaos, and aggression and segregation. So this leads us into the statistics. It's very important to highlight that 97% of all journalists that were surveyed in the United States of America expressed that fake news and misinformation is a severe issue that needs to be tackled. 66% of all bots discussing COVID-19 facts during the worldwide pandemic were spreading misinformation. Absolute misinformation and fake news. 64% of adults claimed that fake news has caused them confusion on just basic facts. These are not small percentages, guys. This is mass majorities, and that's a very important issue. And lastly, I would like to conclude my section by giving an example, a very dear example to me, the Rohingya Muslims. So, because of fake news and misinformation about them and their so-called violence, it's resulted in the dehumanization of them, which has contributed to the genocide of the Rohingya Muslims, which is a very, very sad thing that's happening right now. So, because this was our motivation, we decided that we want to do something about it. And we set out some requirements that we must fulfill in tackling this issue. And so, the requirements is as follows, and I'll leave you with my colleague, Ahmed Mo.
So, starting with the requirements. Our first requirement for this system was for it to be reliable. What do we mean by reliable? That our user could depend on this system, trust this system, and rely on it. Then we went on relevance. If this system isn't relevant with current day events, then what are we doing it for? Then, after having reliability and relevance, we need it to be scalable. People must use it. All users must be able to access it at the same time. And last of all, convenience. If this system isn't easy and isn't quick, the users won't have an incentive to use it. Then we started to implement these in the design.
Okay, so let's simplify how our system works. Any computational task starts with an input, ends with an output. So what's our input in that case? The user will probably be surfing the internet, coming across articles and going through news hosts. And they will suspect that there might be misinformation that they want to know if it's misinformation or not. How are they going to use our system to do that? We provided three ways for that. First, we have our front end. They will be able to copy the URL of the website and paste it directly into our website, or through manual text. They can write the text manually that they suspect might be misinformation. And we also developed our very own browser extension tool. This tool, with just one click of a button, the user will be able to access our tool from any website, which makes it highly accessible and convenient. So what's next? We started feeding our dataset of articles to a large language model, which is an advanced AI trained on multiple text that makes it interfere with humans, like as if it's generating human text or human-like responses. So what did we do with that? We started asking the LLM, can you identify whether this article is misinformation or not? We started testing it on 10,000 articles, but unfortunately the results weren't as we hoped for. So of course we could have trained the LLM and fine-tuned it to our dataset to increase the accuracy. However, this introduced another problem. We will then have to retrain the model every time we increase the dataset or add new articles. As we know, there are thousands and thousands of articles that get published every day. So how are we going to mitigate this issue? We needed a continuously updated system that, without the need of retraining the model or fine-tuning it, to be able to tackle this issue. And that was when we introduced the RAG, Retrieval Augmented Generation.
Now, moving on to the retrieval augmented generation. What is it? What is the RAG? The RAG composes of three main components: the data preprocessing unit, the embedding model, and the vector database. Let's start with the vector database. The vector database basically contains all of our articles, represented as numerical representations, vectors, and we store it with all its metadata, including its content, title, and author. How do we get these numerical representations? This is the role of the embedding model. It feeds our vector database these representations, which they obtain the articles from our data preprocessing unit, which formatted it a way that the embedding model could be able to process it. Let's take, for example, a new article we're going to input. It's get formatted in the data preprocessing unit, then embedded in the embedding model and creates a vector, and we retrieve the top K articles from the vector database that are similar to this article. We then feed all of these articles into the LLM for it to analyze and classify whether this is misinformation or the news is reliable. However, we still didn't answer the question, how will we keep this up to date? How will new articles be able to be inserted into this system? That's where we come up with the web crawler. The web crawler is basically a system that has multiple spiders. Each spider calls a different domain or a source in order to retrieve its news either daily, twice per day, or even 4 times per day, depending on the interval that is decided upon. This then feeds the vector database and keeps our system up to date. However, we found one more problem. In the rare cases that our model presents an incorrect answer, what shall we do? We need to avoid this in the future. So we created a feedback unit. This feedback unit is only authorized for experts and authorized users that are given to by the organization. They give constructive feedback to the output, and is then stored in a different index in the vector database for future runs. That concludes the design with a reliable, relevant, scalable, and convenient system. Now on to the results.
And now for the results. So here you can see our latest updated results that we obtained on our final model that was using our vector database that combined all the complete data sets of NLGT and fake news. And the the evaluation as well was conducted on a test sample that is composed of 4,000 sample articles. And as we can see, here are the results. The accuracy is 85.8%, precision of 88.6%, recall of 72.6%, and finally F1 of 72.81%. And based on these results, we can conclude that we have an overall system with a strong performance. The values achieved here are within or even exceeding the values for each, the acceptable range for each of these evaluation metrics.
And now, let's walk you through our fake news detection app demo. Let me start by explaining what the system actually is. It consists of three components. The front end, which is built by Streamlit, which is a Python framework designed for interactive and responsive user interface. Also, a backend that acts as a middleware, combining the model itself with the front-end services, as well as an analyzing pipeline that analyzes the data and generates the output. And finally, an efficient API that is Fast API, where it integrates into the backend and gives out responsive and augmented results.
And here we start with the sign-in page. In the sign-in page, basically, the user starts his first step in the experience. And this sign-in page is integrated by the backend through front-end calls that provide more security and reliability. So as we can see here, the user, she typed her email, followed by the password, and then she pressed sign-in. Now we can see we move to the main page, which has our main functionality with the fake news detection. So here, the user has two options for the input. He can input the article as a text, or he can copy the URL of the website, as we can see here in the demo. So here he's copying the URL, and he would paste it in the relevant field, and then he would start the generation process through the analyze. In the generation process, we process the input, and then we send that generated result. Here, our generated result is unreliable news.
And not only that, there is a feedback option where the admin users can agree or disagree on the reliability of the URL that they searched for. And it's then stored into a different data set to not alter the main data set that it's searching on under each admin's user ID. Also, the user can add a bookmark and can retrieve later their favorite articles that are also stored into a different data set, which is the Firebase data set. And we can see here as the user will add the bookmark, and it's shown in the bookmarks page. Yes. The user saved multiple URLs. And also for the profile page, where the user can modify or update their username or email, and it's also stored into a different data set, which is the Firebase data set. And here the user will update, which will give a pop-up message for thanks for updating.
Moving on to our final feature, which is the setting page, where the user can change the password or even have some modifications to the notification preferences. Here we show you the changing password option. He inserted his current password and new password, and then he will confirm that new password. By clicking on Change Password, the password was changed successfully. Then we have the notification preferences, and we have the danger zone for deleting the account. Here, we press on the delete account, and then we will give him a confirmation prompt if he would like to continue with the process. And now with an additional feature to give the user more convenient experience through the overlay extension. Here we give the user the ability to actually analyze any input or any article from any website from his website that he's currently using and without the need to go to our web app. And here is a demo showing how the overlay extension actually works. So as we can see, he started the scanning process by opening the web app, the overlay extension, waiting for the result. Here, the article is considered reliable, the output. Another example here for another output. It's the same process, but here he would have a different output. Article contains misinformation. Next, we have our testing. So for the testing, we actually have done multiple ways of testing, either for the model or the application itself. Let's start with the model testing. So the first thing that we had is unit testing, where we actually tested each unit alone by itself to make sure that it's working or it's performing its intended task in the most correct and reliable way. So for example, we had the feedback alone by itself, we had the retrieval system alone by itself, and so on. Then we had the A/B testing, where we compared different versions of the model. So for example, we had one version which had a specific baseline model, specific configuration, and a specific vector database composition. And for the other models, we had different variation or different values for each of these criteria. And this was done in order to identify the model or the final model structure that we had that is performing or having a superior performance as we show in the results slide. Last, we did the performance testing, which was based on to ensure that the model is actually doing its classification of whether the article is reliable or not in the most accurate way and the most consistent way. And this was done by actually running the model on multiple test sets, each containing 4,000 sample articles, and we then analyzed and computed the confusion matrix and the evaluation metrics as well. Moving on to the application testing, we had the usability testing, where we tested the user experience, whether he is having a user-friendly experience while uploading the article or interpreting the generated result or navigating the other features as well. And this was done through the conduction of a feedback or a survey for getting the feedback from the users. And lastly, we had the stress testing in order to check for any bottlenecks or anything. And this was done by actually having a load, an input load that is of a larger size, or having high traffic on the website and checking for any bottlenecks like API timeouts or inference time that is not suitable.
Okay, so now we're going to be talking about the empowerment outcomes of our project. So starting off with we have a business model and a research paper. So for the business model, we're going to start off with the industry analysis. So why does the industry need our product? Well, politically, fake news has played a disruptive effort in the 2016 and 2020 US elections and Brexit. And by 2024, 71% of adults reported that they have encountered misinformation regularly, while 64% believe that it impacted elections massively. Economically, fake rumors are also disruptive because there was a fake rumor about the former President Barack Obama that he was injured in an explosion, caused $139 million US stock market loss. So this shows that fake news doesn't just remove trust, it actually causes immense financial losses. Also, $2.6 billion are annually channeled into misinformation websites. However, with every challenge comes an opportunity. So governments need new and robust tools to counter this misinformation, especially in the fields such as US elections, national security, and public health. Also, the introduction of legislation like the EU's Digital Services Act and the UK's Online Safety Bill is expected to encourage demand for new misinformation tools. And the European Commission's NGI Trust Chain initiative has awarded an additional 1.8 million euros in grant funding to leading European startups combating misinformation. Next, let's talk about our competition. So the market is divided into dominant players and small niche players. For dominant players, we have TrueEpic, which verifies authenticity of photos and videos, and it was funded by Microsoft Ventures in 2021, raising $26 million. The second dominant player is Signal Labs, which identifies harmful online stories, and it has raised about $75 million. For some of the small niche players, we have Kinzen, which combines human expertise with AI detection, and we have Graphica, which tracks how misinformation spreads in networks. However, after our market analysis, we have identified that most startups are pivoting towards business-to-business models, targeting large organizations and governments due to the limited consumer market for misinformation solutions. Next, let's talk about our revenue cost model. So our revenue model is going to be a tier pricing, with the first tier being a free tier, which is limited to 5 articles per month. And this is basically for NGOs and educators. Next, we have the individual plan, which gives access to unlimited articles and analysis for researchers, journalists, and politically engaged individuals. Next, we have the professional plan, which gives access to team collaboration tools and priority customer support, which is for small media agencies, campaigns, and advocacy groups. And last but not least, we have the enterprise plan, which is a custom pricing, offers API access, custom datasets, and bulk analysis. And this is the plan for government agencies, large corporations, and news organizations. Next, for the cost, it's mainly divided into 3 sections. For the infrastructure, we're going to be using FICE as our vector database to store and retrieve our vector embeddings. And this has an additional server hosting at about $400 per month. We're going to use AWS EC2, scaled up to 5 servers, costing about $1,900 per month. And we're going to website host on AWS Amplify, costing about $35 to $70 per month. This includes up to 10 million monthly active users. Secondly, we're going to outsource 5 representatives for customer support, costing about $1,250 per month. And lastly, some additional expenses like marketing and sales and some other miscellaneous costs, bringing the total cost to about $4,000 per month or $48,000 per year.
And now we'll discuss our SWOT analysis. So what are our strengths? We built our tool to cater to various user needs as we offer competitive pricing tiers. We also built a scalable infrastructure that will meet the huge and growing demand on our service that we expect. And as for our unique selling point, we consider ourselves as a continuously updated system thanks to the web crawler scheduler, which fetches the most recent news articles from the most reliable sources. What about our weaknesses? We solely rely on reliable sources, as accuracy in misinformation detection is crucial, as you need high quality content and trustworthy ones. We also just entered the market, and there are already established businesses, which will make it a challenge to build brand recognition. What are our opportunities? We see ourselves, there's a potential to grow into a new market. We can integrate with social media platforms like Twitter and Facebook, where when users are scrolling through their feed, they could come across a misinformation article that they might suspect contains one. We could offer our API services on their platforms, which will allow the users to instantly know whether it is misinformation or not. We also intend to do partnerships with educational institutions and government. What are our threats? It's important to address our threats. First, the competition. As I just mentioned, there are already established businesses and severe ones. They are highly profitable and they know how the business works. We just entered and we need to keep up. What about the privacy concerns? Privacy concerns may arise as we web crawl news articles, websites, which might violate their terms and conditions. Now on to the ethicals.
Some ethical reconsiderations were taken into perspective. Bias can happen when the model is trained on some data where it might favor some people and overlooks the others. Also, a transparency issue might rise where users do not fully understand how the model actually works or how it outputs whether it's misinformation or it's not. And they might enter into the black box area where they do not fully trust the system. Also, there is a high potential for misuse where the system could be handled into the wrong hands and it might create propaganda. You never know. And finally, let's be honest, misinformation isn't the same everywhere. It depends on the language, it depends on the country, on the region, and some people or some countries might perceive this as misinformation while the others do not.
And now we will talk about our second our empowerment outcome, which is the research paper. Firstly, in this paper, we compare between two different large language models, which are Mistral 7B and Llama 3. Firstly, we run these two models on three different datasets, and we choose the third one, which is a mixed one, while the others are fake news Cobras and the Nila GT. And the results were improved by inputting our input, which is RAG, including that we finally yield that Llama 3 with RAG and the mixed dataset yield an F1 score, which approximately equals to 0.8. And we will present it in this conference, which is IEEE conference. Next. Regarding our future work will be depend on four pillars, which are firstly multimodal formats. As it here shows that we can make our model to be run on different sources, such as social media posts, tweets, videos, photos, images, etc. By that, we can provide our users with a much real time checking and also incredible like engaging also experience. Then about real-time fact-checking. Here we mean that we can get instant live speeches, for example, and interviews to be checked immediately. Like imagine in political debates or something like that, we could extract the voice of the speeches and we could check by the journalists using our model either the claims or provided are true or not. Third one is multilingual. Here we could make a translation models which can also translate the languages and provide the users with a wide experience from different multilinguistic regions and also use multilingual data sets. Finally, regarding our mobile application, we could take the advantages of mobile phones as it's widespread across all the world and use the cameras and records or etc. Of its features to take like instant photos or instant images to record them and etc. Thank you.